In this video, I will be solving problem set 4, problem 2, and the beginning portion of this asks for a problem strategy, or solution strategy for the problem. And so basically, this question is a ginormous thinking problem. And I've spent a lot of time just kind of mulling this one over before I actually decided to solve it. But this first thing I notice is really, I have two code words. Essentially, they're the complements of each other. Let's call this C1, or we'll call it caps, I don't know. We'll call this D1, D2, data 1, data 2, are complements of each other. So data 1 is equal to the bitwise complement of D2, essentially. And so really, I can just represent these. I can simplify this problem just by pretending like D1 is going to be 0, and this is equal to 1. So this is the message I want to send, but this is just an encoding of that message so I can better detect and correct errors. Now the next issue is that I need to figure out how many K-maps I need. So the first instinct is to say, well, if I have 4 bits coming in, I need 4 bits going out. I'm going to need 4 K-maps. Well, if these are just related by complements, and actually what I see is that G3 and G2 are going to be equal no matter what, and G1 is going to equal G0, and G3 is equal to the complement of G1. So I was actually creating a minimal circuit for this. Basically, all I need to do is solve for G3, output it into 2 places, and then also send G3 into an inverter to find G1 and put that out to as well for G0. So really, this problem only requires 1 K-map for the correction, and for the detection, basically that I will just need 1 K-map as well. Basically, figure out what the code word is, put the 1s for where there's an error, and the 0 for whenever this is the encoding. So whenever C3, C2, C1, C0 are one of these two, I put a 0. So I'm going to have 2 zeros in my K-map and a lot of 1s, so minimal circuit, easiest minimal circuit would be just using a POS because I have so few zeros, and unless, I can circle a ton of stuff for the SOP, but that's not likely. And so that's kind of the stuff I see before I solve this problem. So I'm going to need 1 K-map for this, 1 K-map for this, and basically I'm going to solve for G2, G1, and G0 with respect to G3. And that's all I need to do. And so basically I just need to make sure that my don't cares are done appropriately, because I'm going to have several here when basically if it's distance 2 between, so if I have 0, 0, 0, 0, I have to pick which one of these code words I want to go to and just make sure I'm consistent with my don't cares.